In this video, I'm going to introduce the concept of compound interest from section 8.4 in our textbook in Math 120. Our definition of compound interest is interest computed on the original principal as well as on any accumulated interest. So when the bank pays you interest in January, they add your original principal plus your interest. And in February, that total amount is treated like your new principal amount, and they pay you interest on the whole thing. So they're paying you interest on money they already gave you. One of the formulas we use for compound interest is this one. A equals P times the quantity 1 plus R over N raised to the power of NT. We've seen most of those letters before. A is still future value. P is still principal, or our present value. R is still the rate in decimal form. And T is still the time in years. The new one is this N. It's the number of times per year interest is computed. We need to look for some key words in our problems to figure out what our N actually is. If they tell us that the interest is computed yearly, then that means that N equals 1. If they say it's compounded monthly, well, there's 12 months in a year, so our N equals 12. If they say it's quarterly, there's 4 quarters in 1 year, so it would be N equals 4. They could also say weekly. There are 52 weeks in a year, so we would say N equals 52. They could say daily, and this one's a little weird. According to our textbook, the banks assume that there's 360, not 365 days in a year, because they assume that there's 30 days in a month. Now, in the real world, most banks nowadays use N equals 365, but I want to stay consistent with our textbook, so when you're working on MyLabs Plus, you've got all the same information. So assume that there's 360 days in a year. If we look at this first example, it says you deposit $1,200 in an account paying 3.2 interest compounded once per year. How much money will be in the account after 5 years? Find the interest earned. They tell us to do 2 different things. We want to find the money in the account in the future, and we also want to find the interest earned. So I'm going to focus on that first question. How much money will be in the account after 5 years first? Because we just talked about our compound interest formula, we know in the back of our minds we should be using that. But when we're done this chapter, when you're looking at a homework or a quiz or the test, you need to know which formula to pick. This key word, compounded, is what's telling us that we need to use our compound interest formula. Just like I did with simple interest, I'm going to write out that formula so it's very clear what I'm plugging all of my numbers into. And just like I did before, I'm going to list out each variable, and as I read the problem, fill in what they all equal. If I read through the problem, you deposit $1,200. The amount I deposit is always my principal. I'm going to fill that in for P. In an account paying 3.2% interest. That is my interest rate. I fill that in for R. Remember, our interest rate always has to be in decimal form, I bump my decimal point 2 places to the left to get 0.032. Compounded once per year. That means that my n equals 1. That's how many times it's compounded per year. How much money will be in the account? I want my future amount after 5 years. My t equals 5. It's already in years. I don't have to do any converting. I'm going to fill everything in. I have a equals 1200 times the quantity 1 plus 0.032 over 1 raised to the power of 1 times 5. When I plug that in, I'll end up with A equals $1,404.687548. Remember, it asked me how much money I will have in the future. My hundredth spot is my cents. This 7 tells me to round up. So I will have $1,404.69 in the account after 5 years. That answers the first question. They also asked me to find the interest earned. Notice when we talked about compound interest, there was no equation that had I in it. We don't have an I equals equation. What we do instead is use some logic. If we originally put in our $1,200 and we now have a little over $1,400, all of the money that it increased by has to be the interest. It's the only way that my bank account could go up. I didn't deposit any extra money. So anytime I'm trying to find the interest, I'm going to do the future value minus the principal. In this case, my future value was that $1,404.69. My principal was my $1,200. That means my interest is $204.69. Make sure you don't forget to do that second part of the problem.